Welcome to lecture series on signals and systems. In up to the previous lecture, we have solved and we have understood many of the classification of the systems. Okay, to name them, we saw a static, dynamic, causal or non-causal, linear or non-linear, time-invariant or invariant, and stable or unstable systems. Okay, so apart from them there are some other classification of the system also. In some of the book they have mentioned them, like invertible systems and inverse systems, something like that. Actually I am not covering all those points. If it is required, please let me know so that I can cover the point on that. Okay, so we will solve one problem based on this, and which you can get in many of the university examinations. Okay, so here is the problem about the system. Okay, so find whether the following system is, all these options have been given, like we need to find whether the system is static or dynamic, causal or non-causal, linear or non-linear, time invariant or invariant, stable or unstable. Okay, so three problems are there. I will solve only one problem here, and the बाकी दो problem जो यहाँ पे मैंने mention किया है, that is for your practice problems or an assignments. Okay, so let me know at the end. You can solve by yourself, and if you get the answers, that is well and good. Otherwise you can comment me so that I will give you the solution for that. Okay, so moving this with the first question, it's about y of t is equal to t plus 1 x of t plus 5. Okay, this is the problem I will be solving. So we will go by one. Okay, so how to calculate a system to be a static or dynamic. Okay, static or dynamic or other words for that is memoryless and with memory, right? So how to do that? If corresponding response of an output is depends on the present input only, then it is memoryless, right? Otherwise, if it requires previous output or it depends on the future input or something like that, then we require memory. So they are the dynamic system. So accordingly, you can see here for t equal to 0, what is happening? Y of 0 equal to x of 5. Okay, by just this example only you can understand the output of the given system depends on the future value of the input. Okay, so it depends on the future input. That's why it is the dynamic system, because it requires the memory, right? Then in the second case, it's about the causal and non-causal. So both of the points are very much similar, because for a causal system it has to be the output response has to be depends on the present input as well as the past input. Okay, and non-causal only the system which if it depends on the future value, right? So since the output of the system is depends on the future value of input, so we can say a system is non-causal system. Okay, I hope these points are very much clear to you, because in both the cases the output is depends on the future value of input. That's why it is dynamic as well as non-causal system. Okay, next it's about the linearity and non-linearity. Okay, so whatever the steps to calculate the linearity and non-linearity of the system we have done previously, we will do it for this also. Okay, so what is the step 1? So we need to look for the response of the system for input x of 1. Okay, so that is x1 of t के input हम apply करेंगे, उसका output क्या होगा? y1 of t, that we will note. So correspondingly what will happen? It's simply changing the nomenclature here. Okay, so y1 of t equal to t plus 1 x1 of t plus 5. Okay, so x1 of t plus 5 का input दिया तो y1 of t output आएगा, ऐसा हम consider कर रहे हैं. Okay, similarly we need to apply the input x2 of t, and correspondingly we will be noting y2 of t as an output response. So it will be y2 of t equal to t plus 1 x2 of t plus 5. Okay, I hope it is clear to you. These are the first two steps of the linearity check. Okay, next, then in the step 3, what we need to do? We need to apply the combined input to the system, and we need to observe the y3 of t. That is, here you can see in the step 3, we need to apply a1 x1 of t plus a2 x2 of t, and we need to record the output, that is y3 of t. Okay, So what will the response here? Y3 of t equal to t plus 1 because we are not changing the other variables, we are changing only the input. So input is a1 x1 of t plus 5 plus a2 x2 t plus 5. Okay, so this is the equation number 1. Okay, then in step 4, what is the second thing we need to do? We need to obtain the output as a1 y1 of t plus a2 y2 of t. Okay, so उसका क्या होगा? a1 y1 of t plus a2 y2 of t इक्वल टू a1 y1 का वैल्यू क्या है? t plus 1 x1 t plus 5 प्लस a2 के बदले क्या होगा यहाँ पे? t plus 1 x2 of t plus 5. ओके, देन उसका दोनों यहाँ पे t plus 1 इज कॉमन, तो वो मैंने बाहर ले लेता हूँ. सो दिस विल बी t plus 1 इक्वल टू a1 x1 t plus 5 plus a2 x2 t plus 5. Okay, that will be equation number 2. Now in the step 5 we will be comparing the output. What are the two outputs? y3 of t will be compared with the a1 y1 of t plus a2 y2 of t. दोनों equation number 1 and 2 will be compared now. So what is an observation we will have? So y3 of t, whatever you got here, is as same as a1 y1 of t plus a2 y2 of t. Equation 1 and 2 are equal. Therefore the given system is linear system. Okay, so it is following the superposition property or principle. Okay, then we call it as it is a linear system, otherwise it is a non-linear system. So understand that superposition property or a principle, then it is very much easy for you to understand the linearity of the system. Okay, next in the fourth case, it's about the time variant or invariant. We need to find out whether the given system is time variant or invariant. तो उसके सबसे यहाँ पे हम क्या कर सकते हैं, उसका भी स्टेप्स हम फॉलो करेंगे. यहाँ पे स्टेप 1 इज इक्वल टू, फर्स्ट इज डिले द इनपुट बाय हाउ मेनी यूनिट्स? t नॉट यूनिट्स. यहाँ पे मैंने पूरा मेंशन नहीं किया है. विथ रिस्पेक्ट टू दिस वी कैन अंडरस्टैंड. ओके, सो इफ यू आर नॉट अंडरस्टैंडिंग, प्लीज गो बैक टू द वीडियो विच आई हैव एक्सप्लेन्ड हियर अबाउट हाउ टू सॉल्व दीज प्रॉब्लम्स. Then come back here and you can understand these problems very easily. Okay, so we need to delay the input by t naught unit to observe the output y of t comma t naught. Okay, so that is the response here. Y of t comma t naught equal to t plus 1. Only the output input is delayed by t naught units, so that's why it is t minus t naught here plus 5. That is I am considering as equation number 3. In the step 2, what we need to do? Replace all the t terms in the given expression by t minus t naught. Okay, throughout the expression. So this will be y of t minus t naught equal to t minus t naught plus 1, because this is also a t term that is changing to t minus t naught. Then x of t के बदले यहाँ पे t minus t naught आएगा plus 5. Okay, that is equation number 4. In the step 3, what we need to do? We need to compare the equation number 3 and 4. Okay, based on this comparison we can say it is a time invariant or time variant. So you can see in this expressions, equation number 3 and equation number 4, y of t comma t naught is not equal to y of t minus t naught. So directly we can say a given system is time variant, because with respect to time it response is changing. Okay, so that's about the fourth thing. And next it's about the stability of the system. Okay, so how to find the stability of the system? For this we need to apply the bounded input. Again, for the bounded input we are considering a unit step signal, that is u of t. So u of t हमने apply कर दिया, that is x of t को as a x of t we will be taking u of t. Okay, then we will be recording the output. So y of t will be t plus 1 as it is रहेगा, x of t plus 5 के बदले वो u of t plus 5 हो जाएगा. Okay, now to find out the magnitude of y of t, I have drawn the graphical representation of the signal. तो उसका सिग्नल मैंने ड्रॉ किया है to make it more clear to you. Okay, तो कैसे किया है देखते हैं हम. Whatever the two parts of the signals are there, that I am considering it as x1 of t and x2 of t. So y of t as यहाँ पे x1 of t multiplied with x2 of t ऐसा हमने consider किया. x1 of t is nothing but what? t plus 1. Okay, t term is there, so it is like a ramp signal. Okay, but it is shifted already or drifted. Okay, तो यहाँ पे क्या होगा, स्टार्ट सब्स्टिट्यूटिंग द डिफरेंट वैल्यूज ऑफ t here. At 0 it will be already 1, at 1 it will be 2, at 2 it will be 3, like this it will be going till t tends to infinite. Okay, and similarly if we substitute the negative values at t equal to -1, it will become 0, -1 plus 1, that will be 0, and at -2 it is -1, at -3 it is -2, like this the amplitude is changing. So this is the graph we will get for x1 of t, that is equal to t plus 1, and it is growing from -infinity to infinity, whatever the values of t are there. Okay, correspondingly x2 of t is the u of t plus 5. Okay, so it is the time shifted unit step signal. Okay, so x2 of t u of t plus 5 है, so क्या होगा, ये एडवांस होगा और ये लेफ्ट शिफ्ट रहेगा. So this will start from -5, और सिंपली ये लेफ्ट शिफ्ट राइट शिफ्ट आपको ये प्रॉब्लम हो रहा है तो क्या करने का, वट एवर द टाइम थिंग्स आर देयर हियर, मेक इट टू 0. ओके, सो t plus 5 equal to 0, t will become -5. So this will tell you that this signal will starts at -5. Okay, and since it is the positive terms, so it is going from -5 to plus infinite. Okay, now both the signal has to be multiplied. So according to the property, multiplication property also we have saw it. तो उसके हिसाब से क्या होगा, whatever the amplitudes at that particular instant of time is there, they will be multiplied. Okay, since for this ramp these signals are there, तो ये as it is आएगा, because u of t का amplitude है जो है this is always 1. Okay, so 1 से जो भी multiply करेगा तो वही आएगा, right? So -5 से पहले जो values होंगे that will be 0, because u of t starts, this second signal starts at -5 only and it goes to infinite. यहाँ पे क्या होगा, ये जो नेगेटिव वैल्यूज ऑफ t का सिग्नल्स रहेगा they will be 0, because -5 से पहले ये टर्म 0 है ना, अगर ये दोनों को मल्टीप्लाई किया तो क्या होगा, सिग्नल y of t, that is x1 of t into x2 of t, that is nothing but t plus 1 into u of t plus 5. -5 से शुरू होगा. What will be the magnitude here? According to the y-axis, it is -4. Okay, because if you substitute -5 here, the x1 of t will be -4. So it will be -4 से शुरू होगा amplitude, ये -4 रहेगा. Okay, यहाँ से शुरू होगा, and where it will go? It will go to up to infinite, no? Because this is also going to infinite, and this side also it is going to infinite. It will go. So the amplitude of the y of t signal is continuously growing with respect to increase in the time. So that's why it is producing, you can say here, for the bounded input, whatever the plot we have done here, the bounded input, that is u of t we have applied here, produces the unbounded output. So you can see here unbounded output ho gaya. So that's why the system is unstable. Okay, so therefore what we can say with respect to the given problem, this one. Okay, so this one is the system dynamic है, non causal, linear, time variant and unstable system. Okay, so that's a complete solution of the given problem. So accordingly you solve other two problems whatever it is mentioned here, and if you find any queries, so you can contact me, you can comment me and I will help you with that. Okay, thank you.